All right, in this video, we'll be reviewing some arithmetic or calculations where we have radicals involved. And so let's get started. On number 1, this is a radical that's not simplified. The problem is if you look at the perfect square factor, or perfect squares, that's these guys, other than 1, if there's any perfect square factor of this number, this radical is not considered simplified. Well, 4 is a perfect square factor of 24. We can write this as the square root of 4 times the square root of 6. Now, if I had another perfect square factor in here for 6, notice none of these divide into 6, I would want to choose a bigger perfect square factor instead of 4. But in this case, we're good. This becomes, well, see, square root of 4 is 2. So we get 2 square roots of 6. So you should be able to simplify radical in this way. Now, this actually is equal to the square root of 15 over the square root of 25. So the square root of 15 over 25 is equal to the square root of 15 over the square root of 25. Notice the square root of 15 is simplified. There are no perfect square factors of 15. So this is the square root of 15 over the square root of 25, which is 5. Now you may recall that if we had a radical in the denominator of a fraction, we had to rationalize the denominator. In this case, we're okay. All right, let's do number 3. When we multiply fractions, we multiply across. So we'll do 1 times the square root of 2, which is the square root of 2, and 2 times 2, that's going to be 4, minus, and we got square root of 2 times square root of 3. Now, it turns out that when you multiply radicals like this, you just multiply the numbers inside. You're going to get square root of 6 over 4. Since we have a common denominator, and by the way, when you're, I'll finish my statement in a second. When you're dealing with problems like this in Chapter 5, you don't really want to mess with your denominators till the end, because normally you're going to have a common denominator and you don't want to mess that up. So even if you could somehow simplify one of these fractions, notice we're going to get 4 for each of these denominators, which is what we want. All right, so finally I have a common denominator, so I can just subtract my numerators, and we're done. Okay, on number 4, when we multiply here, be careful, this means 2 times the square root of 2. When we multiply that by 2, we're really multiplying 2 times, or I should say we want 2 of these guys. This is 2 square roots of 2. If you multiply by 2, you're going to get 4 square roots of 2. Notice we're just multiplying the numbers out front. I could only multiply the radical 2 times another radical like I did up here. So if I did like 2 times the square root of 2, I can't do anything further to simplify that. If I had square root of 2 times square root of 2, that would be the square root of 4, which is actually 2. So in this case here, we're going to have 4 square roots of 2 over 9. And I'm going to keep this positive because I'm multiplying a negative times a negative. And of course, 1 times anything is itself. So we'll get the square root of 5 over 9. So this, now we have a common denominator. This is 4 square roots of 2 plus square root of 5 over 9. Now you might be tempted to do more with this, but these are not considered like radicals. You can only add like radicals. Like if you had 2 square roots of 5 plus 3 square roots of 5, you would add the 2 and 3, and you would have 5 square roots of 5. Just like if you were adding 2x and 3x, it would work very similar. But because these are not like radicals, there's nothing more we can do. And when the book asks for exact answers, they're saying, leave the radicals alone, don't change these to decimal numbers. All right, let's look at number 5. And this one looks quite complicated. So let me show you how we would want to simplify an expression like this, which is something you're going to have to do in this chapter. So this is a complex fraction because you have fractions within a fraction. In fact, you have a couple of them. And there's a nice, really slick trick for simplifying an expression like this. Notice you have two denominators and they both have, or they're both 3. And so we can actually simplify this most easily by multiplying by 3 over 3. If you multiply the numerator by 3, if you did 3 times the square root of 3 over 3, these guys cancel and you're left with the square root of 3 over 1 or just the square root of 3. So 3 times this fraction here gives me radical 3. And then 3 times a minus 1, that's minus 3. In our denominator, 3 times 1 is 3. And 3 times this fraction is going to give me plus the square root of 3. And you could do like I did over here. Now, we've talked about rationalizing the denominator in the past. So for example, if we had 2 over the square root of 3, we would have to multiply that denominator by the square root of 3 and do the same thing to the numerator. So we're really just multiplying by 1. And we'd get 2 square roots of 3 over 3. In this case, it's a little more complicated because we have 2 terms here. Notice we have a radical in the denominator, so we need to rationalize the denominator. I'm going to go ahead and erase here because I think I've got to clear up some space. So what we do is we actually, to get rid of the radical in the denominator, we have 2 terms here. We multiply by a special binomial. It's going to look just like this one, except for it's going to have a minus in the middle here. These are called conjugates. Of course, I can't just do that to the denominator. I have to do it to the numerator. So again, I'm just multiplying by 1. Now keep in mind, I'm going to have to FOIL this out. So square root of 3 times 3, that's 3 square roots of 3. Square root of 3 times a minus square root of 3. Well, that's minus square root of 9, or just minus 3. And we've got our inner product of minus 9. And then our outer product, negative 3 times a minus square root of 3. That's going to be plus 3 square roots of 3. In the denominator, hopefully you remember this just ended up being 3, or 3 times 3, which is 9, minus 3, and you're just going to end up with 6. The reason why is because your inner product and your outer product are going to be opposites. I'll just go ahead and do it in 2 steps. So we have 3 times 3, which is 9. 3 times a minus square root of 3, that's minus 3 square roots of 3. And notice our inner product is plus 3 square roots of 3. And you can see these guys cancel each other out. Square root of 3 times a minus square root of 3, you're going to get minus 3. And so we end up with, let's see, 3 square roots of 3 plus 3 square roots of 3 is 6 square roots of 3. A minus 3 and a minus 9 is a minus 12. All over 9 minus 3, which is 6. Now we can write this as 6 square roots of 3 over 6 minus 12 over 6. And we end up with the square root of 3 minus 2. So all of this just simplifies to the square root of 3 minus 2. All right, last problem. So the main thing is being able to handle this and then working with that expression, the answer that we get. Actually, that won't be too bad because we'll get rid of the radical. So I'm really going to multiply negative square root of 6 over 2 times itself. Well, square root of 6 times square root of 6 is 6. A negative times a negative is positive. So we're going to get 6. 2 times 2 is 4. Plus 1 equals x squared. Now in this case, I think I would go ahead and, let me think about if I want to do this. What you're going to find with problems like this is we like having a denominator of 4 because we're going to end up taking the square root of both sides, and taking the square root of 4, that's a nice thing to take the square root of. So I'm tempted to reduce this to 3 halves, but you're going to find it's easier if we don't do that. And so let's go ahead and write 1 as 4 over 4. Basically, we're multiplying by 4 over 4 here. And 4 over 4 is 1. And so we're going to get x squared is equal to 6 plus 4, that's 10 fourths. We're going to take the square root of both sides. And we do that, we have to do a plus or minus here. We're going to get x equals plus or minus, it's going to be the square root of 10 over the square root of 4, which of course is 2. And so this is a type of equation that you're going to need to be able to solve in Chapter 5. All right, that's it for radicals.